So the third challenge, and we're very excited because this is also the first year this challenge is running. This is the Orbit Few Shot Object Recognition Challenge. And let's get started. Again, following the other two challenges, we'll be going over the challenge description, the data set, announce the challenge winners, and then finally discuss some future opportunities. Beginning with the challenge description, the Orbit challenge invited teams to build a teachable object recognizer for a person who is blind or low vision. What is a teachable object recognizer? Unlike a generic object recognizer, a teachable object recognizer can be taught or trained by an end user to recognize their personal objects after it has been deployed in the real world. The end user would capture a few examples of each of their personal objects, train their recognizer, and then can use this personalized recognizer to identify their objects in real-world test scenes. Central to teaching teachable object recognizers is the ability for the recognizer to learn new objects from only a few examples or shots, which the user collects. The challenge formulates this few-shot object recognition task in the following way. First, teams must train their models for the few-shot task. Then teams must evaluate how well their trained model adapts to new test users. So we take a test user and fade in the training videos they have captured of their personal objects. The model learns these objects from just those few examples. And then finally, the personalized model is evaluated on how well it can recognize that user's object in a new real-world test video. To mimic this, the challenge defines a set of trained users which are used exclusively for training, and then a set of completely different test users which are used to evaluate the few-shot model. Specifically, the trained model must be evaluated on each test user individually. Namely, we loop through each user, giving the model just the user's isolated videos, and then evaluate recognition performance on that user's cluttered videos. Performance is then finally averaged over all test users. And moving on to the data set, to drive this challenge this year, Microsoft has collected the Orbit data set. The data set contains over 3,800 videos of objects recorded by 67 people who are blind, low vision on their mobile phones. Overall, this comes to around 2.6 million frames. And importantly, the data set is grouped by collector, meaning that the objects are grouped by the person who contributed them, mimicking how the challenge task is set up. For each object, a collector recorded a small number of videos, specifically 2 to 10 isolated or training videos, which showed the object by itself, and then 1 to 3 cluttered or testing videos, which show the object in a realistic cluttered scene alongside other stuff. Now onto the exciting part, announcing the winners of the Orbit Few Shot Object Recognition Challenge 2022. We awarded joint first place to the top 2 teams. The first team was Arbitron from Australian National University, who achieved an overall accuracy of 74.02%, and Canada Goose from Hawaii, Canada, who achieved an overall accuracy of 71.79%. Congratulations to both these teams, and both these teams received a cash prize of $2,500 each, sponsored by Microsoft. These winners were selected based on 3 equally weighted criteria. First, performance. This was taken to be the average accuracy across all test users, as we saw in the previous slides. Second was innovativeness. Here, the judges interpreted the team's contribution in the context of how technically novel it was and how useful it was in the context of a teachable object recognizer. The criteria was interpreted broadly, ranging from how robust the model was to Orbit's noisy real-world data to how consistent the recognizers adapted to different test users. A final criteria was the quality of the team's repository, which included both their code as well as the README and then the video that they shared for this workshop today. And finally, coming to the future opportunities, we're very excited to launch the challenge this year as part of the Vizwiz workshop. And as you can see, we have made a great step forward relative to the original paper's baselines. However, there's still a wide scope for future innovation. To highlight some of these opportunities, first and foremost, we need further innovation in few-shot learning. Recognizers must be able to reliably learn from just a few examples per object. Second is robustness, where recognizers must be robust to noisy data captured by real-world users. And third is consistency, where each user will have a different set of objects captured in a different set of conditions. Recognizers must personalize consistently across all these users. And fourth, explainability. We need to think deeply about how to make the recognizer's learning process transparent to end users who may need to adjust how they capture the training data. And finally, computational efficiency. Ultimately, personalization would need to happen on a mobile phone, so the adaptation process must be computationally lightweight. And with that, I will be wrapping up the challenges portion. Thank you to all the teams who participated and to our generous sponsors. If you would like to learn more, you can check out these links about the Orbit Challenge. And we look forward to seeing more teams innovating in this space in next year's challenge.